Okay, let's begin. This is Terengganu. Okay, Terengganu paper 2, section A. Okay, so diagram 1 shows an electrical circuit using a component, electronic component X. So this component over here, okay, is obviously a diode lah. Okay, the one with the triangle and the bar is a diode. Okay, so the component X allows current to flow in, of course, only flows in one way lah. Okay, I think that is the function. Okay, that is the function of the diode. Okay, the function of the diode is to allow current to flow in one way only. Okay. Now, so when the switch is on, what will happen to the bulb? Okay, give the reason lah. So when you turn on the switch, okay, we find that current flows through here, and the only thing we need to determine is, will the current flow through the diode? Okay, in this case, obviously it will lah. Okay, so the bulb will light up. Okay, and why? Now this is very specific to diode, diode, transistor, electronic components. Okay, why will the bulb light up? Because of the way the bulb is arranged. Okay, how is the bulb arranged? Sorry, how is the diode arranged? Not the bulb. Okay, the diode is arranged forward bias. Okay, so forward bias, then that will allow, let the bulb light up lah. Okay, if it is reverse bias, okay, if it is reverse bias, this will be terbalik. Okay, it will look like this. Then this will be reverse bias already. So the current flows through here. If the current flows through here, okay, it will be stopped by this lah. So this is what we call a reverse bias connection. So reverse bias, if the diode is reverse bias, then the current will not flow, will not flow through the diode. Okay, but in our case over here, the diode is forward bias. Okay, so the current will flow. Okay, how to know whether it's forward bias or reverse bias? Look at the direction of the triangle. If the direction of the triangle is the same as the direction of the current, okay, that is an indicator to you that it is forward bias. Okay. All right, question number 2. Diagram 2.1 shows process of a nuclear reaction in a nuclear reactor to generate electricity. Okay, name the nuclear reaction that happens in the nuclear reactor. So again, there are 2 types of nuclear reactions. Either it's nuclear fusion yang kita kasih campur, or nuclear fission yang kita kasih belah. So in this case, you see that there's one big, okay, that becomes 2 small. So it is nuclear fission. Now, based on diagram 2.2, explain how the nuclear reaction continuous, how the nuclear reaction becomes continuous, and how it can be used to generate electrical energy. So this is a 2-mark question lah. Okay, so how does it become continuous? Okay, it becomes continuous through chain reaction. Okay, chain reaction happens when the neutrons, okay, the neutrons released react with other uranium. Okay, uranium in this case. So the neutrons that are released, they react with other uranium. Okay, so that is how the nuclear reaction becomes continuous. Okay, you get a chain reaction, and the chain reaction happens when the neutrons yang kamu bebaskan itu, they react with other uraniums to continuously produce the energy. Okay, now we haven't answered the second part lah, which is how it can be used to generate electrical energy. So the electrical energy, okay, is generated when the mass defect from each reaction. Okay, electrical energy is generated when the mass defect from each reaction is converted. Okay, sorry. Yeah, is converted, okay, to electrical energy. Okay, so the mass defect, okay, this comes from E equals to mc squared. Okay, the nuclear energy formula is E equals to mc squared. Okay, but this M is a very important one. It's not a specific mass, it's actually a mass defect. Okay, kesusutan jisim lah. So, you know, this whole thing, there will be some form of mass that is lost. Okay, so the mass that is lost is actually converted into electrical energy. So that's how we get those 2 marks. Okay, given that the mass defect is 0.1876 U, okay, or AMU in a nuclear reaction, calculate the nuclear energy. So we use E equals to mc squared, okay, but we first have to change the mass into kilogram. So mass will be 0.1876 times 1.66 times 10 negative 27. Okay, so that will be the mass. After that, you substitute in here. Okay, the value C is 3 times 10 to the power of 8. Okay, if you're not sure about where the C values are, sometimes, okay, sometimes, I'm not saying all the time, sometimes they will give you the value in the front. Okay, so in case they don't give you these values, check the formula list. They may or may not give you in the formula list, especially if they don't give it to you in the question. But things like C, the value of C, the value of G, the value of big G, Planck's constant, all these constants are usually given to you and you're not supposed to memorize them. Formulas, certain formulas you have to memorize. Okay, so when you do all this calculation, okay, you should get the answer 2.8 times 10 to the power negative 11 joules. Okay, now one thing to note okay, when we're talking about nuclear energy, because we are talking about at the very molecular level, okay, so obviously the energy value is going to be very small, times 10 to the power of negative 11. Okay, and that's only because we're only talking about one reaction, just this one reaction only. Okay, we know obviously that nuclear energy is a very big amount of energy because there are tons of reactions that happen at the same time. Okay, that's where we get this big energy. So don't be surprised if the nuclear energy you calculate has a very small value. Times 10 to the power negative 11 is a very normal value because that's just one reaction only. Okay, so don't expect a very big number, okay, when we're talking about this. Even when we're talking about energy, photon energy, also very small number because there's one photon only. Okay, and photon is very tiny. So don't be surprised if your energy is times 10 to the power negative something. Okay, that's a very normal number. Okay, number 3. This question is a very strange question. When I looked at it, I was like, oh, okay. So anyway, shows a spectrum produced by mercury lamplight. Okay, so name the spectrum of light. This is called a line spectrum. Okay, and one of the characteristics, actually one of the characteristics is already given. Okay, the lines form. Okay, the lines the lines are formed. Okay, because of the different frequencies. Sorry, is it coming? Yeah, the lines are formed because of the different frequencies of light. Okay, so you have different lines that are formed because of the different frequencies of light. Okay. Okay, so based on your answer in A2, okay, deduce energy released by the spectrum that you named in B1. Okay, yeah, that's why I said it's a very strange this one. Okay, so the energy released, okay, the energy release is discrete. Okay, this is actually what this one lah. Okay, the energy released by the spectrum, okay, is discrete, or you can call it a quantum lah. Or you can also call it in packets lah. The energy is released in packets. But I think the more normal way to say it is actually it is discrete. Okay, so so I was finding this question a little bit weird, partially because of the way the question, cara diorang tanya soalan, and of course the other one is also that it's a very strange thing to ask lah. But anyway, yeah. Now, based on the light spectrum of the mercury lamp, relate the quantity of energy with the frequency, okay, radiated to deduce the meaning of quantum energy. Okay, so this also became a very equally, we have to relate and then after that deduce the meaning of quantum energy. Okay, if you're going to relate, okay, quantity of energy and frequency is directly proportional. Okay, so the bigger the quantity of energy, sorry, the frequency, right? Yeah. The bigger the frequency, the bigger the quantum energy. That's the relation. Okay, the bigger the frequency, the bigger the quantity. Sorry, did I say quantum energy? Sorry, quantity of energy. Okay, quantity of energy. Okay, the bigger the frequency, the bigger the quantity of energy. And then I was thinking, how does this help me to deduce the meaning of quantum energy? Because quantum means that, well, in the textbook, okay, quantum means that the quantity of energy is directly proportional to the frequency. So I'm like, okay, never mind, it's only 1 mark, so I guess this is the answer itself. Okay, the bigger the frequency, the bigger the quantity of energy. If you're not satisfied, you want to have two sentences, it may help to say that the quantity of discrete energy is directly proportional to the frequency. You can also say it this way. Okay, the quantity of discrete energy is directly proportional to the frequency. It's only 1 mark, so I really don't think that you should be giving 2 sentences. But if you want, you can write both. Because the question, they minta dua benda, relate, and then after that deduce the meaning. So it's like, somehow it's only 1 mark. Okay. Now, a laser pointer produces a beam and photon particles of wavelength, yada yada. Given Planck's constant is this one, and C is this one. Calculate the energy of the photon. Okay, so the only thing that you're given is the wavelength, okay, which is lambda. And we know that the energy of the photon is E equals to HF lah. Okay, so obviously we want to find the F first lah. Okay, so how do we find the F? Is V equals to F lambda. Okay, we substitute the C over here, the F we find, and then the lambda is 6.5 times 10 negative 7 to find the F. Okay, once we find the F, then we substitute into this energy formula to get the answer 2.92 times 10 to the power of negative 19. Okay, so again, to remind you that when we're talking about quantum physics, okay, quantum physics, okay, when we're talking about the wave energy or the photon energy, the photon energy, we need to remember that we have to use the wave equation also, except that in the wave equation, we can always substitute the velocity of the wave or the speed of light, okay, as the V. Okay, that's why they give you this speed of light here. So be ready to use these two formulas very interchangeably in the quantum physics punya calculation. Okay, if there is. A lot of the questions that we're doing this year seem to point at gravitation and quantum physics at section A. Seem to be pointing in that direction. So you may want to make sure that your gravitation and your quantum physics, okay, the calculation for these two chapters you should focus on it lah for section A lah, because it seems that it's going to come out in section A. Okay. Well, here we are. Gravitation. Okay, object of mass m is at a height of 3r above the Earth's surface, where the Earth's radius r is 6.37 times 10 to the power of 6 meters. So name the type of motion experienced by the object when it falls to the ground. Is very normal. It is accelerating lah. Accelerating. How do I spell acceleration? Yeah, accelerating. Okay, accelerating with gravitational acceleration. Okay, yeah, this will be the complete answer lah. It's not just accelerating with any acceleration, it's accelerating with gravitational acceleration. Okay, now if an object of greater mass falls from the same position but bigger mass, state whether the type of motion you state is increase, decrease, or unchanged. Obviously, it will still be unchanged, or it will still be accelerating with the gravitational acceleration. Okay, why? Okay, so why? Because okay, the formula for gravitational acceleration is G equals to gm over r squared. Okay, and r is the distance from the center of the Earth. Okay, so we find that, and this m is the mass of the planet. Okay, so we find that the mass of the object really doesn't matter one, you know. Okay, the mass of the object doesn't okay, doesn't matter on the gravitational acceleration. Okay, so the mass of object does not affect the gravitational acceleration. Okay, notice that it is 2 marks, so we have to add another point to it lah. So if the mass of the object doesn't affect the gravitational acceleration, what is the thing that affects the gravitational acceleration? It actually is is affected. Okay, so the gravitational acceleration is affected by the distance from the center of the Earth. Okay, so this is 1 mark, and then this is the other mark. Okay, the gravitational acceleration is only, sorry, the gravitational acceleration is only affected by the distance from the center. Of course, the mass of the planet, but we're assuming that all of this is Earth. So it's only affected by the R. How far you are away from the Earth center is what affects the gravitational acceleration. Okay, now, so diagram 4.2 shows a graph to show the variation of the type of motion you have named in A, where P is from the surface of the Earth. Okay, so first of all, label. So this graph is actually in the textbook. This is the value of G and this is the value of R. How far you are away from the surface of the Earth. Okay, and then state the value of G at the P point. This one is a fact. It's 9.81 meters per second squared. Okay, don't forget the unit. Now, the value of G affects the human growth. Okay, on the table below, state one effect against low G values in the circulatory system and bone fragility. Wow, this is a very factual question. Okay, now blood circulation system, if we have low gravity, okay, so what is going to happen is all the blood is going to go up. Okay, it's going to like berkumpul on our face. Yeah, I know it feels a little bit weird. Okay, so there are a few ways to write this down. Okay, so okay, so blood, okay, will collect on the upper part of the body. Okay, this is one possible effect. Okay, I'm going to give you maybe 2 or 3. Another one is I think it's called facial edema. I think I remember I remember reading it in this one. So facial edema. Facial edema is actually a cause of too much fluid in your face. Kau punya muka akan jadi bengkak sebab terlalu banyak air dan darah lah yang berkumpul di muka kamu. Okay, you can go and Google what facial edema is. Okay, on this one lah. Okay. Now in terms of bone fragility, of course, lack of gravity, okay, kalau itu G menjadi sangat rendah, okay, then it will cause our bones to be more rapuh. Okay, oh gosh, what's the meaning of rapuh? Brittle. Okay, bones will be more brittle. Okay, or you can always say the most famous one now, osteoporosis. Okay, osteoporosis is also very famous lah, the answer. Okay. So yeah, so these are the possible answers. Of course, you don't have to give all 4 lah. You can just give 1 for each lah. Just giving you more than 1 option in case you want any more answers besides this. Okay, 5.1 and 5.2. So this part I'm going to skip all the compare one. I think you can do already. I'm just going to go through the other questions. So what is the meaning of refraction? Refraction is the bending. Okay, bending of bending. Oh, sorry. This is refraction of light. Okay. Bending of light rays. Okay, after passing through mediums of different optical densities. Okay, this is for light refraction. Okay, if it's different, if it is light refraction, then you need to talk about different optical densities. But if it is just general wave refraction, then we just say different densities. We don't really say different optical densities. Okay, give one reason why light undergoes bending after propagating in different mediums as shown. So why does it bend? It bends. Hold on. Give one reason why light rays undergo bending after propagating. So the reason is because it is going through different optical densities. Okay, light propagates through different optical densities, okay, and changes speed. Okay, as it goes through a different optical density, it will change the speed. That's why the light bends. Okay, I think you cannot separate these two, like, light propagates through different optical densities, cannot. Or you cannot just say the light changes speed, cannot. I think you should always mention this as one set. It's going through different optical densities and it will change speed. If it goes from less to more, or if it goes from more to less optical density, okay, then the speed will change accordingly lah. Okay, so you want to mention these two together. When it goes through different optical densities, it will also change the speed. Okay, that's why refraction happens lah. Okay, so this one I'm just going to give it to you. I don't think I'm going to waste time here because I think everyone is quite good at comparing already. So 5.1 is more than 5.2, 5.2 is more than 5.1. The third one is 5.2 is more than 5.1. And this one is the bigger the angle of refraction, the smaller the refractive index. Bigger the refractive index, the bigger the optical density. Okay, the angle of incidence in diagram 5.2 is changed to 70. Calculate the refraction, the angle of refraction R. First of all, we need to find out what is this one lah. Okay, so we have we have the n equals to 2.42. Okay, so we want to use the formula of n equals to sine I over sine r. So your I is 70 degrees. You can find the value of sine r lah. Our n is 2.42. Okay, n is 2.42. So you should be able to get the value of r equals to 22.85. Okay, so again, everybody, this is more like a guidance lah. Okay, so yeah, I'm just going to give you the guidance and the final answer. Okay, I hope you can do this on your own lah. Otherwise, I got no time to finish all 3 papers. Okay, all right. 6.1 shows 2 identical bottles, P and Q, filled with sand, floating stationary in water. Okay, so we have this. Okay, both are filled with sand, but Q has more sand apparently and is deeper in the water lah. Okay, so the question is, bottle Q floats stationary, okay, because it's lower than the buoyant force, greater than buoyant force, or same as the buoyant force. Obviously, is same. And the key word is float stationary. Okay, if it is going down, means the weight is bigger. If it is going up, well, if it is going up, if it is floating and going up, then it's a different case. Then the buoyant force is bigger than the weight. But it's floating stationary, means neither going up nor going down. Okay, so the weight is the same as the buoyant force. Okay, compare the weight, Q will be more than P, the volume of the bottles immersed. Okay, this you can see from how much is inside the water. Okay, so obviously Q is more than P. The weight of the water displaced by bottles P and Q. Since Q is more inside the water, obviously Q will be more weight lah. Okay, now relationship between the weight and the volume. So the bigger the weight, the bigger the volume. Okay, now this second one, the relationship between the weight of the water displaced and the weight of the bottle. This is a very tricky question. According to Archimedes' principle, the weight of water displaced equals to the weight of the bottle. Sorry, yeah, equals to the weight of the bottle. Okay, that's according to that's according to Archimedes' principle. Weight of the bottle that is actually in this one. Okay, but it is very, very likely that there are some of you who will say the bigger the weight of the bottle, the bigger the weight of the water displaced, which is actually proven by these 2 points. There. If you look at 1 and 3, you can actually say that the bigger the weight of the bottle, the bigger the weight of the water displaced, which actually is not wrong also. Okay, so I'm going to leave these 2 with you lah. Okay, I feel that this answer, okay, so this is the marking scheme punya jawapan. Okay, because it's according to Archimedes' principle. Weight of the water displaced equals to the weight of the bottle. Okay, and again, this is a occurrence that happens in Archimedes' principle. Only Archimedes' principle only, this kind of thing will happen. So the weight of the water displaced is equals to the weight of the bottle. Okay, but you can also argue that the bigger the weight of water, bottle, okay, the bigger the weight of water displaced. Also can be argued that way. Okay, so I wouldn't know lah. Okay, I wouldn't know. Maybe if this kind of question comes out, you will have to choose one lah. Okay, this is the marking scheme answer, but I really see no reason why this answer is wrong. I would actually give it correct also because it is according to the answer in 6B. Right. Okay, so I would give the red color answer a more correct mark. But oh well. Okay, diagram 6.2 shows a boat with 2 passengers and loads moving from the sea to the river. Okay, so the immersed level of the boat increases as it moves towards the river. So what should be done to make sure that the boat will not sink? Okay, so this is very normal lah. What do? You take the load away lor. And okay, so what should be done? So you put the or remove the load, okay, from the boat. Okay, why do we do that? So that you can say when you remove the load from the boat, okay, so the weight of boat decreases. Okay, weight of boat decreases. You can say the volume of water displaced decreases, or the weight of the displaced water decreases lah. Okay, but the law that is involved, okay, in this one is the flotation law. Sorry, the law of flotation. Flotation, not really Archimedes law. Okay, Archimedes law, Archimedes law is the weight of this one. Buoyant force is equals to this one. Okay, we're not really talking about buoyant force, we're talking about floating law. We want to make it float. Okay, so I think flotation law is covered very, very briefly in chapter 2 in form 5. Okay, but this is the law of flotation. Law of flotation says that if the weight is equals to the buoyant force, then it will float. Okay, and we want it to float, like we don't want it to sink, because law of flotation also says that if the weight is more than the buoyant force, then it will sink, which you don't want. Okay, so we have to kind of differentiate between Archimedes principle and law of flotation. Archimedes principle says one thing: buoyant force is equals to weight of water displaced. But this one, why is it that I choose law of flotation? Is because the question says what should be done to make sure that the boat will not sink. So we want it to be the buoyant force, the buoyant force is bigger than the weight. Okay, this is the flotation law. Okay, so the flotation law has 3 aspects to it. Okay, buoyant force bigger than the weight, buoyant force is smaller than the weight, and buoyant force is equals to the weight. Okay, will determine whether it floats or sinks. Okay, but Archimedes principle only talks about the buoyant force, which is equals to the weight of water displaced. Okay, all right. I think I know where this class is headed already. I think I will have to do another session. Okay, diagram 7.1 shows heating element and electric bread toaster. Heating element lagi balik. So boring already, this question. Okay, what is meant by the specification of 240 volts and 100 watts? Okay, so when is this a toaster? Toaster. Okay, when the toaster is supplied with 240 volts, 240 volts, sorry, 240 volts power supply, it will dissipate 100 joules of energy per second. Okay, anything similar to this is fine lah. Okay, ini hanya ayat saya sendiri saja lah. Okay, it will release, also cannot necessarily dissipate lah. You can say the word release lah. It will release 100 joules of energy per second. Okay, I think that's fine. Okay, when the electric bread toaster is connected to a 240 volt supply and used to this one, calculate the current, okay, that flows with this one. So this is a very standard one, P equals to VI. Okay, so you use P equals to VI and you should be able to get I equals to 0.417 amps. Okay, use the P and the V from this question. Okay, now a student conducts an experiment to compare the heating effect of bread toasters PQ and R. 2 slices of bread are toasted at each time. Table 7 shows the result of the experiment. Okay, so we have bread toaster here, potential difference, current, and the time to toast 2 slices of bread. Okay, yada, yada, yada. So everything is given here. The good news is everything is in seconds. So you can actually calculate the energy that is supplied. Okay, so we use the standard formula, which is E equals to VIT. Okay, yeah, E equals to VI. Sorry, I'm dreaming here and there. In case you cannot remember lah, okay, so I always hold on to the PET formula, P power equals to energy over time. Okay, and if you're familiar with You know, whenever we do heat questions, we always say PT equals to MC delta theta. This one is actually the formula for energy. Okay, and just now I said that P, the formula for P is V times I. That's how I get VIT lah. Okay, PE equals to PT. So P is VI, so I get E equals to VIT. Okay, so when you calculate all this, okay, you should get P equals to 1.296 times 10 to the power of 4 joules. Q is 1.2 times 10 to the power of 4 joules, and R is 1.152 times 10 to the power of 4 joules. Okay, so you do, and you see the energy supplied lah, okay, by each toaster. Okay, so the potential difference is the same, it's just that the current that they're using is different. And the time that you use to toast 2 slices of bread is also different. We find that the bigger current has a shorter time, the smaller current has a longer time. Okay, but when we look at the energy that is being used, we find that even though you use a longer time and a smaller current, you use much less energy than the one that is much more current but faster, okay, which is 1.296. So using your answer in 7C, state the most suitable bread toaster, okay, to toast breads. Okay, so I would go with R. Okay, I would go with this one. Why? Because the energy that you use is the lowest lah. Okay, so the lowest energy usage or most energy most energy saving. Yeah, you can do that as well. Okay. All right. Okay, question number 8. So diagram 8.1 shows 2 photographs of the Tacoma Narrow Bridge in Washington State, USA that collapsed in July 1st, 1940 due to resonance. Wow, I think I've shown you this video before, have I? Okay, so what is the meaning of resonance? So there are a few components into resonance, okay, that we need to talk. The most important thing is the word natural frequency must be there, okay, and then of course maximum amplitude. Okay, these two must be there. Natural frequency and maximum amplitude. So resonance is vibration. Okay, vibration caused by an external source, external wave, external force, sorry. Okay, vibration caused by an external force that has the same natural frequency and oscillates at maximum amplitude. Yep. Okay, the key words to this are again natural frequency and maximum amplitude. Of course, it must come from an external force lah. Dia bukan dari dalam. Dia kena tiup dari luar dan ngam-ngam dia same natural frequency as the object and will force it to oscillate at maximum amplitude. Okay, so based on diagram 8.1 and the data taken from in the shipai.org web, the blowing wind has a speed and frequency of 19 meters per second and 0.6 hertz respectively. Calculate the wavelength of the wind. So the answer is obviously 31.67 meters per second. The formula is V equals to F lambda. You want to count the wavelength. Okay, this is a lot of words for a very simple calculation question lah. Okay, the speed is 19 and then the frequency is 0.6. That's it. Okay, no need to think so much. Calculate the wavelength, you get 31.67 meters per second. Okay, now diagram 8.2 shows 2 shock absorber springs in the suspension system on a motorcycle. Okay, using appropriate physics concepts, explain the use of appropriate materials and specific designs to further improve the suspension system on a motorcycle and riders' comfort while traveling on uneven roads based on the following aspects. So you want the length of the spring, Okay, and then of course the number of oscillations produced while receiving a shock, and the type of material of the spring. So this is like combining two topics in one. So this is not just waves, but it is also apa itu Hooke's law. Okay, so we want usually we want a shorter spring lah. Okay, because again, everybody, the idea is that we want comfort, okay, while traveling on uneven roads. Okay, so we want a shorter length of spring. Okay, so because shorter length of spring, if you remember from Hooke's law, okay, shorter length of spring will mean a bigger spring constant. Okay, bigger spring constant usually is also associated with stiffer lah. The spring is stiffer, dia lebih keras. Okay, so bila dia lebih keras, when you go on uneven roads, it won't boing so much because that is very uncomfortable lah. Yes, it's a little bit more painful because you know dia keras, but it's better than kamu begini, which is actually more dangerous. Yeah, so we don't want that. We want a shorter length of spring, so you get a bigger spring constant. Okay, the number of oscillations produced when receiving a shock. That means bila tiba-tiba dia termasuk lubang, how many oscillations you want before it is on? Obviously, we want lesser lah. Okay, or lower number of oscillations. Okay, we want a lower number of oscillations so that you have less vibrations. Okay, so that it's more comfortable for you lah. If it's more vibrations, nanti belum lagi you haven't even finished vibrating, your next lubang already sambung lagi vibrate lah. So you don't want that lah, obviously. Okay. The type of material for the spring, usually we will do steel lah. Okay, steel or anything that is hard metal lah. Okay, but usually steel is the very standard one for motorcycle. Okay, because it is stronger. You can also say stiffer. Okay, any one of this is fine lah. Okay. All right. So that's the end of the Terengganu paper. And I've taken an exact time of 1 hour. Okay, I've taken 1 hour to do this. Okay, there's a question over here. So why does this bridge, this one, I think, I can't remember. I think I must have showed this video once in one of my classes. So this is a bridge. Okay, this is a bridge. This is a true story that really happened. There's a bridge in Washington State, USA that and there was a very strong wind that was blowing lah. Okay, ada angin yang sangat kuat yang sedang meniup-niup lah. Okay, and it just so happens that the frequency of the wind, okay, the frequency of the wind was the same as the natural frequency of the bridge. Okay, so every object has its own natural frequency. Okay, we are all vibrating, or we are all vibrating at certain frequencies, and we all have our own natural frequencies now. So it just so happens that the wind that was blowing, wind or typhoon, I think it's a wind, wind that was blowing at the exact same natural frequency as this bridge. And what happened was, because it was blowing at the same exact natural frequency, it was blowing at the exact same natural frequency, it caused the bridge to start to mengayun lah. And bila dia mengayunkan, so you are thinking that, you know, dia sedang mengayun, and because of all the strings, it's going everywhere, all over the place lah. Okay, and remember, when resonance happens, you're not just vibrating together, you're vibrating with maximum amplitude. You know, so you are really vibrating lah. Okay, you're really vibrating. I can share this in the group later lah. And what happens is you know it continuous lah. The wind was not stopping, so it was continually vibrating until the bridge cannot take it anymore lah. They finally broke lah. So yeah, so that's what happened to this bridge lah.